Hello everyone, myself Ashish Desai, Assistant Professor, Register of Technology, College of Engineering. Today we are going to discuss the field robotics. So basically the field robotics which is focuses on deploying autonomous robots in dynamic and unstructured environment. So which is useful in the industry where the human interaction is challenging or risky. So there are the applications which is use of the field robotics. It is agriculture, mining industry, the space exploration, military, and disaster response. So these are the area uh, we are looking for the field robotics. Then the key characteristics of the uh, field robotics are the first is autonomy. So in that autonomy, it operates with a minimal human intervention. Then adaptability, it is function in varying unpredictable conditions. So this is for the adaptability. So every condition it can be adapt and then it can be work over there. The next is about sensing and perceptions. So using the lidar and camera and GPS sensor for the navigation, and it can be capable for their work. So this is about the main characteristics for the sensing and perceptions. The next is mobility. It is designed for rugged terrains and underwater and aerial operations. So it is fully designed for the any conditions. So which is available in a characteristics. So this is the main characteristics are the field robotics. So whenever the designing the field robots which is in different areas, so we are considering these four characteristics. So first is autonomy, second is adaptability, third one is sensing and perception, and fourth one is mobility. So after that we are going to discuss the types of field robotics. So in agriculture robots, that is for automated farming and harvesting and pesticide spraying, so it is useful for the that field, that is about agriculture robots. So the next field robot is mining robots. So whenever the mining there is work that like drilling or haulage and inspections, so these are the areas we are working with the mining robots. The nextly, that is about exploration robots. So that is about maybe space rovers. So example is NASA station, which are we are covered the explorations. Then deep sea robots. So it is available in the water. So this also we are working with the working for that exploration. So exploration robots are available. Then next is about military and defense robots. So this for the surveillance, bomb disposal, and recognition assistance. So this should be required in a military and defense robots. Then next is about disaster response robots, search and rescue. So search and rescue and firefighting, as well as the hazardous matter handling. So we are using in a nuclear plants, which is useful this in this field, that is about disaster response robots. So these are the different robots which is useful for the as a field robots. The next is about technology, which is used in field robotics. So we are taking the AI and machine learning for which enables the decision making and for the using of adaptability. The next for computer vision, that is about object detection and environmental mapping, so which can be done in a computer vision. The next is about robotic manipulation, which is handling with object in rough conditions. So anywhere any rough conditions, so that can be a robotic manipulation is required. The next is wireless communication. So here the remote monitoring and coordination we can possible with wireless communication. Then energy system. So we are working with battery efficiency, as well as we are equipped with the solar power and fuel cell equipped that robots. So which is useful for the energy system. So there are different this technology which is useful for the field robotics. So we are taking with the decision making by AI, as well as we are taking the manipulation through the different areas. So different conditions we can survive over there. So these are technology which is useful for the field robotics. So now we are going to discuss the next part, that is about challenges in robotics. So doing the challenges, we are going to discuss this point, that is about environmental sustainability. So which is adapting the unpredictable terrains and weather. That is about the environmental uncertainty. That is called as that Colby should be possible in environmental conditions. The next is about prolonged operations in remote locations. So energy constraints energy constraints should be required over there, and the consumption communication limitations, so connected in isolated areas. So this also possible. There is the challenges, then cost and maintenance, so high development cost and operational upkeeping, that is about challenge. The next is safety and reliability, so it is ensuring the interactions with human and surroundings. So safety and reliability is required over there. So these are the challenges areas we are having this. So majorly we are energy constraints are more problem, because whenever at remote locations we are working in the forestry or at that is slam. So we are working with this, that is big issue for the energy constraints. So that is the main challenge for the field robotics. Now we are discussing the simulation, or you can say simultaneous localization mapping, that is SLAM. So it is a most crucial technology in field robotics, which is enables robot to map unknown environments while determining their locations simultaneously, and it is essential for autonomous navigation in unstructured terrain such as mines, underwater zones, disaster sites, and space exploration. So these are the different areas we are covered, which is by using this SLAM. So key components of SLAM is we are using the different type of sensors, that is lidar sensor, that is then say cameras, IMU, that is IMU is nothing but inertia movement units. So in that content we are different using accelerometer over there, and then GPS is there. So different sensors we are using for the perception sensors. And then next about localization. So here estimating the robot position with the related to the generative map. So that's final will be localizations and mapping should be required. So constructing a real-time map of the environment, it should be visualized, and then we can go for this activity. So this is about the mapping. Data association, identifying the previous visited locations and to reduce the errors. So that is called as a machine learning method. So that is data acquisition is required and data capturing. After that we can get in the analyzing. So this kind of actions we can to take there and then to reduce the errors. So this is for the data association, that is key component. Then loop closure, so correcting the positional drift over time, so that can be minimized. So this is about the uh, loop 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 closures. And then next is about slam algorithms. So here different algorithms we are using for the uh, tracking positions. So that's why we are using the extended Kamalan filter or Kamalan filters used for probabilities filtering for tracking positions. Graph slam consider a graph-based model for optimization. Visual slam, so utilized for the cameras and features detection for mapping. So these are the areas we are giving the different algorithms, and then we can getting the determine the locations. So simultaneously, which is in unknown areas. So this is the possibility which is created in a slam. The next is about application of SLAM in field robotics. So that in autonomous vehicles. So we are using the self-driving cars and agriculture machinery. So nowadays the Tata has launches the tractor, so which is fully autonomous vehicle, and which is finding the gaps and all the area altitudes and longitudinal, so we can find it, and then the correctly it can be work for bidding as well as harvesting. So this is kind of actions we are doing with the autonomous vehicles. Next, that is about exploration of robotics, which is in a Mars rovers and ocean floor scanning. So it is also useful for the exploration. So this is uses of SLAM. So SLAM is very important. That is about simultaneous localization and mapping. So this should be possible in disaster response also when navigation collapses. So at that time we can search and rescue operations we can doing with the this SLAM operated the that wheeled robots. So this is also main area we are finding in the disaster response. Now we are going to discuss the future trends. So what are the future trends are there? So there is advancement in AI for autonomous decision making. Then next is about Storm robotics for collaborative tasks, integration with IoT and cloud computing. Then next future trends for the development of bio-inspired robotic system. The next is about suitable power sources for extended operations. So this is about the future trends which is operated for the field robotics. So nowadays we are getting more and more response for the that robot. So which is maybe development for the bio-inspired, or maybe now in an AI with autonomous vehicle. So these are the kind of actions we required for the that robots, so which is in the future trends. Now we are going to discuss the conclusion. So that is about the field robotics is a revolutionary industries by enhancing the automation and efficiency. So we know that different areas we are having that lags are there. So we can finding over there and then we can accommodate by the that field robotics sectors. The next is continuously technology advancement will expand and their capabilities and applications. Then future innovations will focus on the autonomy, safety, and sustainability. So these are area also we are having the searching area. So these are the concluded part of the that portion. So we are having the field robotics is much revolutionary area, and then we are taking the more decision making capabilities using different technologies, that is SLAM and other the AI ML technologies, and then wireless communication technology we can use over there, and then uh, replaces the gaps. So this is the content which are discussed in this field robotics. Thank you.